It's my pleasure to be back here in New York. I actually lived here for 12 years, including New York City and Middleport, New York. And I've actually been working on bedded salt caverns in this state since 1976 at Silver Springs, at Dale, New York, at Bath, Savona, and now at Watkins Glen. What I'd like to speak with you about tonight is what we're calling an engineered approach to storing hydrocarbons in solution mine salt caverns. All over the world, internationally, some of the facts of storage are that there has been successful storage of billions of gallons of LPG products for over 50 years, including propanes, butanes, ethanes, ethylenes, Y-mix, and Mont Belvieu in Texas is the largest salt dome in the world where there is storage of liquid products. But Kansas has over 600 caverns that are storing butane and propane. We have storage other storage in Texas, Louisiana, and of course in New York. All over Europe, all over Canada, in Armenia, where I was able to do some work for World Bank. There were 29 caverns developed there about the same time as our first, quote, natural gas storage cavern was developed here in the United States. In addition, we do have billions of cubic feet of natural gas since 1962, stored in caverns in Texas, Louisiana, Mississippi, Alabama, New York, Saltville, Virginia, Dawn, Ontario, Fort Saskatchewan, Azerbaijan, Armenia, and all over Europe, Italy, Germany, France, England. In fact, the ones in England are all embedded salt. They've been there for years and years. In addition, we have over 700 million barrels of crude in the Strategic Petroleum Reserve, and I was one of the lucky ones who was involved in the original conversion of some old caverns of Olin Chemical into oil storage. And I worked for 10 years on putting the first, or helping to put the first 500 million barrels in salt domes in Texas, Louisiana, and Texas and Louisiana. All the sites are there. What we're looking at here since I first got into the business are improvements in drilling equipment and methods. There are a lot of things that the roughnecks don't have to do today because there is equipment to make the pipe up, break the pipe out. There is equipment to catch the mud instead of squirting the mud all over the place, creating safety problems. We also have drilling improvement in casing quality. Although I will say some of the bedded salt caverns that were developed in New York, at Tully, New York, were installed in the 1800s. They happen to be cast iron pipe. And when that pipe was pulled out 25 years ago, you could still read the name of the manufacturer on the outside. Of course, we don't use cast iron pipe anymore. We use the top quality steel. There are also order of magnitude improvements in logging and in sonar surveys. The first sonars were run by Dow Chemical in the late 60s for their own caverns. And then Birdwell in Bradford, Pennsylvania did sonaring. And then there were a couple companies formed in Texas and Louisiana who now have what I would call, and I hate to use the word state-of-the-art, but they are the best equipment that could be used for monitoring these caverns. And all of the sonar devices are based on the research and development that was done for finding submarines and other things in the ocean for the Navy. So we have made big improvements in the sonaring, whereas we were talking maybe plus or minus 10% accuracy in the 70s. We now claim to have 1 to 3%, or the service companies do 1 to 3% accuracy. And we do multiple sonars. We do multiple sonars so that we can show from one period in time, and you'll see the overlays on these cross sections. The sonars were run in 1975, 1985, 1990, 2000, whatever. You can see the changes, and sometimes only a finite amount of increase in the height or increase in the diameter of the caverns. Logging is just something that I don't believe. I was born 10 years after the first well was logged in France, and all of the documentation was done by hand. I cannot believe what I see today, where they can give the permeability, which has been always a tough thing, to show what the migration of hydrocarbons are, both in oil and gas wells and also in our storage fields, our storage reservoirs. And quite frankly, the mechanical properties logs that we run now, gamma ray, neutron, density, and sonic, with the sonic and the density, we can determine what the rock properties are, what the Poisson's ratio and other technical numbers are that go into evaluation of the strength of the salt and the overlying beds. In addition, we've been doing finite element analysis based on those rock mechanics data and also on core data from the cores that we actually extract when we drill the wells, from the overlying beds and from the salt themselves. It's actually a marvelous improvement in that type of evaluation. Mechanical integrity testing using nitrogen now is what we do. Originally, all of the storage was installed, well, not all, a lot of it was installed simply by doing a hydro test, where the pressure, the cavern was increased in pressure to whatever the gradient would be. Here in New York, it'll be somewhere between 0.7 and 0.75, most likely, for these caverns. Other places that it's stored at higher pressures. We don't do just hydro tests anymore. We do hydro tests periodically as we before we even run a nitrogen test. But what we do is, after the cavern is excavated to its maximum diameter, radius, whatever, we'll pull the pipe, solution mining pipes out. We'll put a new string of tubing in close to the bottom of the cavern, and that will be our brine string. We then inject nitrogen down the annulus between the production casing, and we get that nitrogen interface below where the production casing is. And we monitor it until the temperature of the brine and the temperature of the nitrogen have stabilized. And at that point, we take an interface with the density tool run by wireline. 24 hours later, we do the same thing, and we determine what the movement of that interface is. Because the temperatures were stabilized, in a tight cavern, there should be very little or no movement. There is some effect, believe it or not, by the tides. The tides do affect the interface. In fact, the moon, the phases of the moon affect the interface. And once we determine after 24 hours or whatever period we need to know, the state requires 24 hours for the first one. We check that interface again, and we run a temperature and pressure survey. Excuse me, when we stabilize it, we run a temperature and pressure survey. We then run it again 24 hours later to see where the interface has moved, if it has moved, and measure the temperature and pressure again. In a tight cavern, they very seldom ever vary, within less than 0.5% for a tight cavern. We've been doing this now for at least the last 22 years.